So now let's talk about two proportion test. So when conducting a hypothesis test that compares two independent population proportions, the following characteristics should be present. You've got two independent samples that are simple random samples that are independent of each other. Again, that means they don't depend on each other. The number of successes is at least 5, and the number of failures is at least 5 of each sample. We saw this in one proportion test. It's the same for the two proportion test. So a lot of growing literature states that the population must be 10 to 20 times the sample size. Don't worry about this. We're not going to have to worry about it in this class, but in the real world you would. So if you were doing this, say like you're looking at two different groups for your work and you pull those samples, make sure the actual population is 10 to 20 times larger than that sample. So comparing two proportions is a lot like comparing two means. And a hypothesis test can determine if the difference in the estimated proportions reflects a difference in the population proportions, and it's going to follow an approximate normal distribution. So it's going to follow that normal distribution curve like what we saw in one proportion test. So for the hypotheses, remember these are a lot like what you've seen before when we did hypothesis testing. So we're dealing with two groups proportions. Proportion of group 1, proportion of group 2, and we're comparing those based on the directions. Again, remember the null hypothesis always has to have that equal sign in it. So let's do an example. Researchers conduct a study to find out if there's a difference in the use of e-readers by different age groups. Randomly selected participants were divided into two age groups. In the 16 to 29 group, 7% of them 7% of the 628 surveyed used e-readers, while 11% of the 2,309 participants, 30 in order, used e-readers. Okay, so let's look at the hypotheses. Again, I just want to know if there's a difference. I didn't care if it was less than or greater than, I just wanted the difference. So I'm going to go with the hypothesis stated that for the null, the proportion of group 1 equals the proportion of group 2. The alternative is the proportion of group 1 does not equal the proportion of group 2. So proportion of 1 or sample 1 is the 16 to 29 year age old group. Proportion 2 or sample 2 is the 30 or older group. So I wasn't given the exact numbers to put in for my trials and my events, so I'm going to figure those out. For P1, which is sample 1, the number of events is 628 times 7%. So I get 43.96. I'm just going to round up. Remember to round up when you have people so you can count them all. Again, the number of trials is 628. For sample 2, let me make that look prettier. I don't like the way that looks. Hold on. I don't want it to be confusing. So for sample 2, or P2, the number of events is 2,309 times 0.11, which is 11%, to give me 253.99 or 254 because I'm rounding up. And again, the number of trials is 2309. Okay, level of significance is 0.05 since it's not given. Remember, if I don't give it to you, assume it's 0.05. All right, so let's show how to do this in Minitab. Again, I'm going to go in Minitab. Let me show you how to do this. And again, if you get confused, you have everything you need here on how to figure it out. Okay. All right, so I'm going to do this. Let me show you how to walk it through. I'm going to go Stats, Basic Statistics, Two Proportion Test. All right, summarize data. So for my first one, it's going to say, I said 44 out of 628. And then for sample 2, it's 254 out of 2309. Okay, now remember, always go back, check yourself. So as you can see here, I had 44 out of the 628 and 254 out of the 2,309. Always check yourself just to make sure. Go to options. Okay, so this is going to change because I said it was 95% because I did not have, it wasn't given to me. And for this one, I wanted to know if there was a difference. So I'm going to do this one for my difference. My hypothesized difference is 0. I'm not going to try to do that. And then my test method, I'm just going to put estimate the proportions separately. I'm just going to do it there just to make it easier on myself. I hit OK, hit OK. This is what I get. Okay. Method, it tells me what I'm looking at. Descriptive statistics, it gives me sample 1, it gives me the N, gives me the event, and it gives me the sample P. Does the same thing for sample 2. It shows me the difference between the two proportions, and it gives me a confidence interval for that. Gives me the null and the alternative hypothesis, gives me my Z value because I'm doing the normal approximation, and it gives me my P value. All right, so let's talk about it. And again, here are the slides showing you what to do. All right, so my Z value is negative, let me go right here, is negative 3.30. My P value is 0.001. All right, let me make this better. Okay, at the 0.05, I'm comparing my P value to my level of significance, and because my P value is less than my level of significance, I reject the null. And again, why did I do that? Because my P value was lower. Okay. So my conclusion, at the 5% level of significance, there's significance evidence that there is a difference in the use of e-readers by the different age groups, okay? Because remember, let me go back to my hypotheses. Oops. So here's my hypotheses. So because I rejected this null hypothesis, something's going on. I don't know if it's less than, I don't know if it's greater, I just know it's different. And that's really what the question was asking. In the real world, this is how you really usually run these tests. First thing you do is compare to see if the groups are different, and then you try to see how they're different.